Here we have a problem on logarithm. Okay, let's go over the question. If n equals to m factorial, where m is a positive integer greater than 1, then the value of 1 over log n to the base 2, positive log n to the base 2 keeps going up to 1 over log n to the base m. Okay, so to evaluate this expression, what I'm going to do is, in the first term, I am moving this term log n to the base 2 to numerator. In logarithm, whenever I move a logarithm from denominator to numerator or numerator to denominator, have to switch the base and argument. So if I switch the base and argument over here, I'll be getting log 2 to the base n. So because I moved this logarithm to numerator, so I switch the base and argument. So the same thing I have to do for each term in the given series. So when I move this logarithm in the second term, when I move the logarithm n to the base 3 to the numerator, then I have to switch the base and argument over here, then I'll be getting log 3 to the base n. And the same thing will happen for the third term, then I'll be getting log 4 to the base n. And if I do the same thing for the last term, I'll be getting log m to the base n. Okay, here I'm adding more than 2 logarithms with the same base n. So whenever I add 2 or more logarithms with the same base, what I can do is I can take logarithm once with the base, what I have for the given logarithms, and have to multiply the arguments. So this is a product rule of logarithms. So the arguments are 2, 3, 4. I have to multiply the arguments 2 times, 3 times, 4 times, up to m. Okay, here log to the base n. In front of this 2, I just assume there is 1 multiplied. There is 1 times, 2 times, 3 times, 4 times m. Okay, since I've done 1 multiplied over here, so is there any change in the original stuff? No, because here we have to, even if I write 1 multiplied by 2, still it results 2. So the stuff over here, the stuff over here, both of them are equal in value. Okay, here we have 1 times, 2 times, 3 times, 4, it goes up to m. So what can we write for this one? So we can write, so for this expression we can write m factorial. Because already we know that, for example, if I have 5 factorial, it can be as 1 times, 2 times, 3 times, 4 times, up to 5 we have to write. We have to start multiplying the numbers from 1, and we have to multiply up to 5 whenever we have factorial. This is the concept of factorial. For example, if I have 3 factorial, I have to multiply 1 times, 2 times, 3. So here we have 1 times, 2 times, 3 times, up to m. So this expression can be written as m factorial. Okay, so in the next step, already we know that n equals to m factorial. That is, the value of m factorial is n, that's given in the question itself. So we can plug in n for m factorial. So in the next step, I'm getting log n. So when I plug in n for m factorial, I'll be getting log n to the base n. Usually in a logarithm, if the argument and base are same, the value of such logarithm is 1. But we have to notice an important thing over here. If the argument of logarithm is equal to 1, the value of such logarithm will be 0. Okay, here we have to make sure, if I want to say that the value of this logarithm n to the base n is 1, so the value of n should not be equal to 1. So because if log 1 to the base n, if the argument of the logarithm is 1, the value of this logarithm is 0. So I have to make sure this n is not equal to 1, so that the value of log n to the base n can be 1. Okay, so here there is an information. M is a positive integer greater than 2. When m is a positive integer greater than 2, then it will be more than 2, like 2 means like it may be 3 factor or 3 or 4 factor, something like that. So when m is greater than 2, definitely the value of n cannot be equal to 1. So the value of n will be greater than 1. So the value of log n to the base n equals to 1, because the n is not equal to 1, n is greater than 1. So the value of this logarithm is just 1. The correct answer choice for this question is option A.